In the venerable annals of physics, there exists a foundational and timeless discipline known as classical mechanics, a profound realm that unveils the principles governing the motion of physical bodies. This classical tapestry, woven with the threads of force, mass, and motion, lays the groundwork for understanding the macroscopic world and stands as the cornerstone upon which the edifice of physics is built. Newton's laws. At the heart of classical mechanics lies the monumental triad of Newton's laws of motion. The first, a testament to inertia, asserts that objects at rest remain at rest, and those in motion persist in a straight line unless acted upon by an external force. The second law, expressed with the elegant equation F equals ma, links force, mass, and acceleration in a profound dance. The third law, the law of action and reaction, unveils the reciprocal forces exchanged between interacting objects. The gravitational ballet. Classical mechanics extends its embrace to the celestial ballet through the law of universal gravitation. Sir Isaac Newton's gravitational law, an enchanting force that transcends the earthly realm, dictates the mutual attraction between masses and guides the orbits of planets, moons, and comets with celestial precision. Projectile motion. In the terrestrial theater, classical mechanics paints the arcs of projectile motion. Be it the graceful parabolas traced by launched projectiles or the calculated trajectories of missiles, the principles of motion under gravity become the choreography of projectiles in flight. Energy and work. The discipline unfolds its narrative through the interplay of energy and work. The concept of energy, whether potential or kinetic, becomes the currency through which systems exchange motion. Work, the transfer of energy through the application of force over a distance, emerges as a pivotal player in the dynamic interplay of forces in motion. Conservation laws. Classical mechanics reveals its elegance through the conservation laws that govern the physical realm. The conservation of energy, where the total energy in an isolated system remains constant, becomes a guiding principle. Similarly, the conservation of linear momentum, a testament to the persistence of motion, stands as an enduring law. Rigid body dynamics. As the narrative extends to rigid bodies, classical mechanics becomes the masterful storyteller of rotational motion. Torque, the rotational analog of force, dictates the rotation of objects. The conservation of angular momentum becomes a guiding principle, influencing the behavior of spinning tops, wheels, and celestial bodies. Harmonic motion. The celestial symphony continues with the study of harmonic motion. Classical mechanics explores the rhythmic oscillations exhibited by systems, whether the pendulum's graceful sway or the vibrations of strings in musical instruments. These harmonies become the resonant echoes of classical mechanics. Collisions and impulse. In the theater of interactions, classical mechanics choreographs the dynamics of collisions. Impulse, the change in momentum, becomes the pivotal force orchestrating the outcomes of collisions, whether in the microscopic realm of particle physics or the macroscopic world of everyday collisions. Extended applications. Classical mechanics transcends the confines of theoretical elegance, finding applications in engineering, technology, and everyday life. From the design of structures to the optimization of machinery, the principles of classical mechanics shape the physical world around us. In essence, classical mechanics is the timeless saga of motion and force, a narrative that unfolds with grace and precision. It is the enduring melody that resonates from the macroscopic to the celestial, providing humanity with the foundational understanding to navigate and comprehend the mechanics of the physical universe.